I was showing it to somebody and I was like, you see how right now we're not, doing this to scale and it's not working. And I kind of like slapped it against this smooth surface and it stuck. And I was like, and then the person I was with, she was like, wait, it worked. And I was like, it does work.
That was Capella Kerst, the founder and CEO of geCKo Materials, which produces a bio-inspired dry adhesive. In today's episode, Capella and I discuss what it's like going from academia to building a team that can take a product from the lab and turn it into a scalable business. Going from Stanford PhD student to startup founder is a trajectory we've seen before, but in this conversation, Capella breaks down some of the learning curves, like what it takes to earn credibility outside of the lab, how to navigate investors as a deep tech founder, and what goes into building the founding team that will make or break this product. I'm your host, Isabelle Johannessen, and this is Build Mode, and this season is all about building your team. geCKo Materials won second place in Startup Battlefield 2024, so before we dive into this conversation, I'd like to remind everyone that applications for the Startup Battlefield 2026 are now open. So if you're building an early stage company or have an MVP, apply for the program at techcrunch.com/apply. And if you want to take these conversations into the real world, then be sure to join us for TechCrunch Disrupt, happening October 13 to 15 in San Francisco. Tickets are on sale now at techcrunch.com/events. And be sure to use code BuildMode15 for 15% off all ticket types. We can't wait to see you there.
Yeah.
Hi, Capella.
Hello.
So good to see you. Thank you for joining us.
Thank you so much for having me. It's an honor to be on the show.
Oh, thank you. We were just talking about how I feel like we've been seeing each other at events and quickly catching up, but today is our chance to finally sit down and get the real scoop on what's going on with geCKo. So how have things been going with geCKo since you did Startup Battlefield in 2024?
So we've tripled the team. So we've hired some phenomenal people that sometimes I just pinch myself and I was like, they're coming to work for me. This is amazing. And we just have such a great community and culture where people are truly excited to be in the office working day to day. We've had some really exciting update with our customers. We had that announcement that we did at TechCrunch this past October. The car companies that we're all working with are progressing nicely and moving forward. I'm going to do a ton of customer visits this next coming quarter.
Oh, wow.
Yeah,
Okay.
yeah.
On the move.
Yes.
So I got so excited to jump into all these updates because I know what you do. But for those who are listening, let's take a whole step back and introduce yourself and tell us what geCKo even does.
Great. So I'm Capella Kerst. I'm the founder and CEO of geCKo Materials. We make a revolutionary bio-inspired dry adhesive. We are currently on the International Space Station, but we also help customers here on Earth, like I mentioned, semiconductor companies, car companies, robotics, automotive, pick-and-place robots, even drones. So we're all over the place. Do you want me to show you the famous wine demo?
How about it?
So what I'm known for is holding a full bottle of wine.
That's a good thing to be known for.
And then it falls off as soon as you tip it over. And so geCKo Materials, this is geCKo Materials, super lightweight. As I mentioned, bio-inspired dry adhesive. So 1-inch tile supports 15 pounds vertically. 6 of these 1-inch tiles can actually pull a car on this exact ground. This ground would be perfect pulling. If we could get a car up here, we could just yank. Yes, next time. And so they're micro hairs. So diameter of a hair on your head is 100 microns. This is 1/100th of that diameter of your hair. And they're all angled this way. And then this one's angled this way. And as soon as you engage, I pull that wine bottle up, you create a shear force. And so through that shear force, we're able to attach instantly and detach instantly. And so that has been just the background, and then people applying it and putting it on their pick and place, eliminating suction, airline, and vacuum dependencies, as well as just helping customers save energy, time, and money across all industries.
Well, I mean, from the moment I saw you pitch at another conference and then on our stage at Disrupt, I mean, this is a real breakthrough and a really amazing innovation for so many different industries and so many use cases. Let's talk through, how you discovered this, how you came up with this idea. It was in your PhD, right?
Yes, my PhD. So I came into the lab after 15 years of R&D research. I joined the lab and I helped with the 4th generation. And then I was like, wait, this should be a mass product. I quickly discovered it took 48 hours to make. And I was like, nope, this isn't a mass product, but we can make it a mass product. So then I just head down, really due diligence, and a lot of research and a lot of long hours. And I had a massive breakthrough in which I was able to patent that work. And we can make our multiple units now in under 15 minutes. And so, yeah, that's okay. Now you're a company. Now you can be scalable. So I finished my PhD in 2020. fun times and started it right after. And I saw all the applications we were working with, and I was like, we can make this a commercially viable product, but I had to have it be done at mass scale. So my PhD was in mass scaling, production, and manufacturing.
I mean, I have so many questions, but I want to ask, how did that breakthrough feel? When was it a moment that something just clicked, or I mean, was it a longer process? Like what did that feel like?
It was phenomenal. It was a process in which I was actually explaining to somebody. I've been debating, like, do I keep this story and like, make it the classic? But no, I always have to be truthful. So I was showing it to somebody and I was like, you see how right now we're not, doing this to scale and it's not working. And I kind of like slapped it against this smooth surface and it stuck. And I was like, and then the person I was with, she was like, wait, it works. And I was like, it does work.
Like mid-pitch, you discovered that it worked. Oh my gosh.
And then I called over two other people and I was like, look, because I had been like, ideating with them and like doing different like molding techniques and stuff. And like I had pulled this thing off the mold and it, wasn't working. And I was like, I didn't crack it yet. And when I showed her this and then I pulled over the other two people, they're like, oh my gosh, it actually works. And it was such an exciting moment to have that. And then so we took a little selfie in like our clean room outfits, and it was really fun. And then I went to my advisor and I showed him, and he's just an amazing man. I love Mark Kokoski and BDML, and he like looks at it, studies it, he's like playing with it, and then he gets up and he goes to the lab. So we're in his office, goes to the lab, and he calls somebody over, and he's like, "Look what Capella just did." And he shows them, and I was like, oh, he's showing somebody else. Like, I obviously did something good. I made it, yes. And then I was lecturing this last fall, actually, at Berkeley. And the Berkeley professor that studied the biology aspect of it, while Stanford made the man-made aspect, after my lecture, he started tearing up. And he's like, I've been waiting for so long for this to become a commercially viable product to help really make a difference in people's lives. And it was just, like, so touching to, like, actually see someone's research that they've been working on for a couple of like decades at this point, right? So it's now been over 2 decades of research.
That's amazing.
Yeah.
And talk to me a little bit about how this can change people's lives. I know right now, I mean, you're in many different spaces, quite literally in space and on Earth. But eventually, I mean, I remember you kind of saying that eventually this could replace Velcro, even in like home and consumer applications. What is sort of like the grand vision of how people could eventually interact with geCKo?
The same way they interact with Velcro nowadays and other attachment mechanisms, those command strips that ruins people's walls, and maybe they get less deposits back from their
guilty.
So this could actually attach to very smooth and micro smooth painted surfaces, windows and walls. There is a company that is currently doing some R&D. I won't name the company because we're in NDA, but TV mounting on a window.
Wow.
So then
on a window.
Lordy
Lou. Wow.
So then you could attach it super thin, and then you can like move it around the house and do things like that. Or they're also thinking with meetings and meeting spaces, you could just pop up one of their like LED screens and just like project and have it at different, places around the room. So that's been really exciting. And we did a first proof of concept with that and it passed their test. So I'm really excited about that.
So what percentage of your customers are like use cases that you kind of set and go to market with versus people coming to you and saying, I have a wild idea, get this?
80% have a wild idea and it is amazing. And I love it every time I hop on a call and I don't know the company or the person I'm talking to. And it's just like, they just come at me with this idea. I'm like, that's phenomenal. I've never thought of that before. And so that's really exciting. It's actually very high percentage. And I think it's thank you to TechCrunch and all the other media sources that we've had write articles about us that just attract people. And they're like, I read about you. I saw this video. I did this. And then they'll just send us like, I have this idea. Would this work? And then we just hop on a call.
Wow. And so when you think about scaling the company, I mean, are there some of those wild use cases that can then become repeatable that then you can go to market with that concept after you've tested it with the initial idea creator?
I don't know if we will ever go to market with any set solution. Okay. We are always going to be the geCKo materials. Like we sell this in this flexible form and also a hard tile form, but we don't sell the gripper that I showed at TechCrunch Disrupt this past year that was on that Fanuc robot. You can attach to any robotic arm. That system, once you pay for geCKo materials, we freely license that design to our customers. So we don't sell that end solution. So these customers that we have, we give them the material, they embed it, and then sell it to their customers. Like Apple. Apple's a customer of ours, embedding it, selling it.
So you're not so you were licensing and not like selling a custom or building a custom solution for anybody, or?
It's not really, well, yeah, it's like a fine, it is actually very interesting, the licensing part. I am very passionate about people having innovation that is sustainable, cleaner for the consumer and the workers making the actual product. So we're freely licensing it. We're selling our product, but freely licensing any designs that we have come up with. So yeah, so there's like a fine line of like, people are like, some investors are like, well, you should sell your licensed design. I'm like, no, because I really, really, really want it to take off in a big way and have as little impediment in the market.
Let's take a little bit of a step back. So this is a spin out from Stanford University, from your PhD. I'm always curious to understand better what the process is like for spinning out from a university, because there's often times where, the university owns percentages of it. That makes it, more complicated to raise later. So talk to me a bit about how you had your breakthrough moment. What did you do next?
Yes. So after the breakthrough moment, lived on that high for a couple of days, and then back to lab. And then a couple months later, got up the courage to really address my advisor in a very we need to have a serious conversation about me spinning out this company and starting it. And then I asked for permission, basically, because it is his lab. And then I went through and I asked every single person who had ever worked on geCKo materials throughout the last 15 years if they would like to join the company, if they would like to be compensated in any way, if they'd like to be an advisor. And I had amazing conversations with all PhD students, and they were just all so excited that it was actually being marketable and their research could actually make an impact. So that was really exciting. And then I graduated.
Congrats.
Thank you. And then I approached OTL. So it was a fine, I did approach OTL before, but properly I had to finish my PhD or leave the program to do that. So they had known there was conversations, but I had to have certain things in place to say, now I have a company. And actually, thinking back, because it was 5 years ago, super exciting. I had to find a legal team. So Stanford was very nice. They gave me a list of 30 lawyers that they work with. And they said, you have to have one of these as your lawyer. So I did start it early enough in my PhD that I kind of knew what was coming. But then I had to wait until okay, I'm done with my PhD. I'm ready to pull the trigger. So that last month of my PhD and then the first month after I graduated, I spent just interviewing lawyers and finding out about case studies, what other people got. I interviewed other CEOs. How did you work with Office of Technology and Licensing? What deals did you get? What did you push? What didn't work? What got pushed back on? And so I just learned a ton. Picked my lawyer, and then we went at Stanford.
Oh, man.
Yeah, I was like, I want a good deal because I want this to be a big company, and I think it'll benefit everybody. And then Stanford has a long process, which is fine, but pretty quick, actually, talking to other universities. Very, very easy to work with, actually. Very nice. And so this was 2021, and it was a lot of legal paperwork, a lot of things that I read and studied and tried to understand, and then finally agreed upon a document and move forward. So we have royalties. Actually, just signed our royalty check to Stanford yesterday.
No, wow.
Yeah. It's due this time of year. And then they have a percentage of equity. But then during our raises, they have the option, if they want to invest, that they have to be let in the round, which isn't a bad thing.
Right.
I don't know.
Yeah, sound too bad.
I was like,
Boo-hoo.
if you're already in the round, yeah. So then they actually gave us money this last round, which was great. Yeah. Oh, that's something else. You asked a question earlier. We also did fundraise.
Yeah.
Yeah, and had a very successful round.
Which round was it now?
It was a priced seed round. The terminology, it's like an A, a seed, a pre-seed.
A spicy seed round.
Yes,
No.
yes. Whatever you want to call it. We did a priced round, and it was a lot of work, led by an amazing investor. Kitty Hawk was our lead, and we had phenomenal, Alumni Ventures came in.
Great. Congrats. When did it close?
July. We kept it open a little longer for this one investor that was very amazing. And all of my investors, I've been so blessed because the first round I raised was in 36 hours.
Let's talk about that for a second. Who, what, when, where, why, and how. Why in 36 hours?
It was so fast. It was 2021. We just got our lead for the pre-seed round, and I went to a really fun happy hour with some amazing folks.
Famous last words.
Yeah. And this guy I was chatting with, I had my famous wine bottle, obviously, because I took that with me everywhere. And this investor was like, I want to end this round now. I will wire you money right now. And I was like, you'll wire me money right now. I was like, but you have to sign the safe. And he's like, doesn't matter. I'm wiring you money. And I was like, okay. And in like my head, I was like, okay, I just met you. I need to do a little diligence on you. Things are moving quickly, but I don't know, why not? And I was like, give me a second. So I went across the room to somebody who was actually already in the round. They were an LP in our lead investor. And she also that night was like, I also want in separately. She's like, I have never funded direct companies, but I want to fund yours. And I was like, okay. So she was close to this gentleman. And so I took her aside and I was like, okay, can you give me like the skinny on this guy? Can I do some due diligence? And I was like texting some other people to do like another background check. And she's like, if he wants in your round, let him in. And I was like, okay, this is coming from you. Like, I trust you a lot. And so I went back to him. I was like, okay, here's our banking information. And he wired me money right in front of me.
Oh,
it was great.
My gosh.
Yeah.
So, I mean, first of all, what room was this? Whose party was this? This is not a normal party. This is a different kind of party.
It was a Climate Ventures.
Yeah, okay.
Yeah, party. And it was just a happy hour at the Dutch Goose. Yes, in Palo Alto. Classic Stanford, Silicon Valley.
That is a really wild story.
So. It was. Yeah. And it was just like, yeah, which is just the hot new deal. And it was crazy because it's hardware. And in 2021, obviously fundraising was easier. And I totally acknowledge that. Like, it was a lot easier to get money back then. But still, it was still software focused. And yet, we were hard. I think it's because I held a wine bottle.
You know what? That'll do it. That gets us every time. But, I mean, I think even when I remember reviewing your application many years ago now, 2 years ago now, I mean, yes, it's hardware, but it's also something that you can clearly see how this can scale and be massively impactful, right? I think a lot of the challenge with hardware is like, it can be so niche and it can be so expensive, but you have been able to scale this so quickly.
Yes. And we have it in very exciting this past week. One of the things that I researched in my PhD, but I hadn't ever put into full production, I gave to my engineers when we were planning 2026 out, and with everything that's going on, I had a message and they implemented it and had a massive break. And this is like a phenomenal, I'm dropping like a Taylor Swift Easter egg right now. I'm dropping my Easter egg. We had a massive breakthrough last week that was like really exciting. Yeah. And I'm so proud of the team. My team has blown me away time and time again.
Let's talk about your team. So you were talking about some new hires that are just so very exciting. Tell me a little bit about them.
Oh my gosh. One worked at the South Pole in the research lab, and he knocked on our door with his resume in hand, like hard cut. And I was like, one, I'm impressed that you like came and found our door.
You traveled all the way from the South Pole and found little old us in Palo Alto.
Yes. But it's great. And on his resume, I was like, are you serious? Like, this gentleman did research and worked in the South Pole. And it's crazy because it's an international, kind of like the International Space Station, but you can get off of this a lot less than you can get off the International Space Station. Like, there's 8 months of just the harshest winter where there's no boats in and out. There's no flights, no boats, no food, like nothing. At least the International Space Station, we can like pop up food in 8 minutes. Did you know you can send up food in 8 minutes to the ISS?
Wow, I didn't.
Yeah.
It's easier to get to the International Space Station than the South Pole. That is
during the cold months. Yeah, which is crazy. And I know that because of Sunny, the famous astronaut I had the pleasure of meeting and spending a day with her and
Anna.
I cliff jumped with her.
With an astronaut.
Yes.
When you told me that at a party a couple months ago, I'm like, Capella, what?
It was so fun. But I really got to like know her on a personal level, which is really impactful to see what the astronauts really, have challenges with, what's really fun for them to do in space, and how we can make a difference in their day-to-day lives. Especially in researchers of such like the International Space Station or the South Pole. He was been talking about, some different things like, oh, I could have used this down there for like XYZ. And it's like, we should send this down to that research center. So we're trying to figure out a way to get down and help the South Poleans.
I have no idea what South Poleans. Let's go with that.
Yes.
But so give us a little more context. Like, what are some of the challenges in space or at the South Pole that would be solved by geCKo materials?
Yes. So payload costs in space. SWAB-C, that's size, weight, power cost. So it costs a lot in fueling, which ultimately translates to our climate and energy and pollutions, which is a massive problem that we're having right now. So we can lower those significantly. We're also passive. We can help space be more sustainable. So as you know, the International Space Station is being decommissioned. There are a couple folks looking to build a new one, but hopefully geCKo Materials, and I can say this now because we have a paper published. We make these 2x4, so you roll it up tight. Think of, those slap bands that you hit. Similar concept where like it's like a thin, and then you hit it, and then it becomes a tight roll. So similar concept where you kind of like snap this pole out. It's actually really crazy, and like you could definitely get injured while doing this, but you snap out this thing, and it rolls out to this like 8-10 foot like cylinder that with geCKo Materials makes it so it doesn't, when you're compressing it, it doesn't have any warpage or any in structures. You want to make sure that like your tension and compression and elongation, it all stays in a stable state. And so I'm like trying to think of words that aren't like super nerdy and technical that people are like, what did she just say? But basically, like when you're pressing on something, it'll buckle and then snap and break. So you want this to have a bunch of like poles, so then you can make a building structure around it. But with geCKo Materials, you could also detach it. You could either roll it up or move these to make a different size room or structure. So we're sending materials up to space to build in space more sustainably. That's just one example.
Wow.
And then for the South Pole, in really cold environments, not a lot of things can attach very easily because of the cold. So you have glues that are brittle that will break and things like that. So think of like a really old thing of like duct tape you've had for years, or just Scotch tape, and you try to use it and you're like, or a Band-Aid that's really old, and you're like, the glue doesn't work anymore because it is expired. With geCKo Materials, we don't really expire. So we have that 120,000 times. So once you attach to it, later you could detach, but you could leave it attached for years and be okay. My advisor has a little gecko hanging on his window that's been hanging there since I've known him, and it's been 10 years, which I hate to admit that I started my PhD over 10 years ago. I don't like to talk about it.
I love that. And so, I mean, there's the element of temperature involved in this too. So very cold temperatures. Are you guys doing anything in incredibly hot climates?
Negative 115 degrees Celsius to 350 degrees Celsius.
Woof.
Yes.
Yeah.
So we can be on the outside in the International Space Station and deep space.
So many exciting things. And so I wanted to back up for a second because, I mean, hearing you talk about this, like you are the perfect person to run this company, right? I mean, so much passion and knowledge, and I mean, everything that you really live and burn for this company. And I always am, inspired to see you and talk to you about this. I am curious though, like when you spun this out from Stanford, like there were other people that were working on the research and stuff. Like, did you ever get any pushback, or did any of those people join the team, or what was sort of the process of like deciding like I'm going to run with this and like come with me, or I don't know if you pay them out or whatever the deal is, but how did that sort of come to fruition that it's now your baby?
So on the mass production side, I actually was the only PhD student. So that actually made like the patent is just in my name. I was the sole inventor, with Mark Akoski being my PhD advisor, of course, adding to that aspect of things. And he's listed as a PhD advisor. I asked Mark loves to run a lab. He's not going to quit and run a company, which some professors have, but Mark is like, no, I like, research. And he's an amazing faculty and advisor. Then when it came to that list of students, PhDs that contributed to the microstructure itself, no one really they love their jobs. They were like, maybe in the future, and so and I said, my door is always open. You always have a place and a home here. And there's one particular person who ran a lab at Jet Propulsion Laboratory and now is head of Amazon Robotics. And I actually tried to get him to be an official advisor. Conflict of interest, because Amazon will hopefully soon be a customer.
She said it here first. No.
Now they're like, actually, no. But if we can help them, I mean, we're helping their competitors.
Yep.
And, why not?
Yeah, really, why not?
Yeah, they're lost. You know what I mean? Like, it's not the point where you're like, okay, you don't want to use us? Fine, you're lost.
Suit yourself.
Yes.
But so what gave you the conviction early on to go for this and that this could be a big business?
I think when I was doing a demo table for some very impressive and influential people, I'm not going to name their names because they're very controversial right now, but they're very famous. And they came to Stanford, and we had a little table, and I was demonstrating some of the use cases, and then just like going through with the PhD applicational projects. Like we had Honda, and it was a collaborative project between like their engineering team of ASIMO and myself and some other PhD students, and just seeing that, and like Honda, Ford, Toyota, GM, like there were so many customers, specifically like cars. We also did like things with Oculus and Amazon and Walmart at the time. Interesting. But I was like looking at it, and I was like, wait, this could actually make a difference. Like we're actually having breakthroughs and getting feedback from these other engineering teams of people in the industry that are liking geCKo materials. And they're actually asking, well, I would love to implement this, but I need this at scale because I can't buy and I can't make these one-offs. I need this for, full production line. I need this for all of our industrial robots. And that's when I was like, this can be a company because it's a need that we're helping people. And going back to another question you had earlier, in the manufacturing line, because we're a public benefit corp. So for us, profit doesn't always matter if we really care about our customers and the health of the workers working at these other companies. So really passionate about that. You have less lung damage and less hearing damage because you're switching to geCKo materials. Because when you're on a pick and place robot and you eliminate that suction airline vacuum dependencies, it's super loud. It creates a lot of hazardous oils actually in the back room that people have to get rid of once a week. Sometimes you don't get rid of them, so then they create more toxins in the environment, or they contaminate local groundwaters if you're in a place that's probably not the US where we have OSHA laws, which is unfortunate.
All right, so we were talking a bit about, the university spin out, and I guess I have seen a lot of startups recently that are trying to help facilitate like research from universities to become commercial ideas. And they're, startups that are trying to facilitate that. But I'm curious, like, what do you think is the major bottleneck of, the brilliant research and scientists coming out of these universities? Like, why are these ideas not becoming commercial? Because there's so many things that could help so many people, but something is stopping it. What do you think it is?
That's a great question.
Keeps me up at night. Yes, thought I'd ask you.
Thank you. I'm going to think about this more after this too. I think it's the transition of having people truly passionate about the solutions that they're working on. And I think that some things get lost, that some things aren't sexy enough to get enough funding. And then some things, I was actually talking to this with a partner at a very large VC. But again, I'm just, for TechCrunch's sake, I won't get too political or anything. And they're like, they just throw money. Like you see these around, these mega seed rounds, and you're like, what could you possibly do with $500 million? Like seriously, at that stage, like how many people are you hiring? How quickly are you burning through money? And why don't you have milestones? Like there's going to be a shift in the VC world, which I think actually will benefit exactly those startups with the solutions, because things that are not sexy, not in, aren't getting the funding because of that sake. Also, it is a little hard. Like when you have somebody kind of come in and they don't really know, like say you have like a business person. I'm not going to dish the MBAs, but like, an MBA hops on an engineer.
Leave us alone. I know.
Hey, I just did mine from a short MBA from NYU Stern, so I'm part of the club
there
now.
There you go.
It was an online.
Like you don't have enough degrees, Capella.
Yeah, I didn't get enough degrees. NYU Stern, it was a phenomenal. It was the EFL, like deep tech specific. Anyway, that aside. So, but like business people are known to hop onto engineers and be like, let's start a business. And then a lot of it falls on the engineering shoulders. And so making that shift of having people truly be passionate about changing the world for the better and not just passionate about running after money, I think also is a big thing. A lot of these things that people are running after, they're just running after for money. They think like, oh, it's quick. And just now, the amount of networking events I've been to, I can like spot it in like a heartbeat. So I always offer to any of my VCs that have raised with me or any VCs I really like, I always offer, let me do due diligence for you. Like, let me be a background check, like free of charge. I would love to help make impact. Like if this company truly can make an impact in the world, identifying it and seeing how I could help them along.
But so to wrap up, what is sort of the next major inflection point for geCKo? What is your next major goal?
Our next major goal is to be in full line production in these assembly lines, and that's what we're really pushing for. So it's a little bit of a longer journey than originally thought of. We had a lot of good R&D, we've passed a lot of initial testing, and now we're doing like the initial pilots, which is great. So the next inflection point will be in all major kind of semiconductors and car facilities in their production line. That'll be, yeah. And then when the new ISS goes up, that'll be a really big inflection point too. So
exciting times ahead.
Super exciting.
I'm glad to hear they take you seriously because you are so authentic and impressive. And I always loved catching up with you and talking with you. So congratulations on all of your success for that's, what's happened and what's to come. And thanks for joining us today.
Thank you so much for having me. It's been an honor, and I love you and the show, and it's great to be here.
Build Mode is a TechCrunch podcast. Each episode is produced and edited by Maggie Nye and hosted by me, Isabelle Johannessen. Our art and design is also by Maggie Nye. A big thanks to Morgan Little, who leads our audience development, the Foundry and Cheddar video teams, and most of all to you, the builders, and everyone else in the wider startup community. We'll see you back here next time.